We propose guided data augmentation, or GuDA, a human-guided data augmentation framework that generates expert-quality augmented data. GuDA enables offline reinforcement learning and imitation learning methods to learn effective policies from limited demonstration data. Imagine we are training an autonomous vehicle to park in a parking lot using a few demonstrations. Since a parking lot is relatively uniform, we can generate augmented experience by translating and rotating the agent. Most existing data augmentation strategies would apply these transformations randomly, ultimately producing suboptimal data. Since offline reinforcement learning and imitation learning methods perform best with expert data, GuDA imposes a series of user-defined rules on the data augmentation process to ensure we generate expert-quality augmented data. In this example, GuDA translates and rotates the car such that it successfully parks. The remainder of this presentation highlights our physical robot soccer experiments, in which a now V6 robot must score a goal from the two easy and hard initializations shown here. Our demonstration dataset contains a single trajectory of the robot scoring from the center of the field. This demonstration is highly suboptimal since the expert was trained in a low-fidelity soccer simulator shown to the left. To generate expert augmented data, GuDA translates, rotates, and reflects the segments of our demonstration to show the agent kicking the ball away from the sideline and then into the goal. We then extract a policy using implicit cue learning, an offline reinforcement learning algorithm. We compare GuDA against agents trained without augmentation and with a data augmentation strategy which augments the demonstration randomly. We also use our expert demonstrator as an additional baseline. In the hard initialization, our expert policy typically kicks the ball out of bounds. Policies trained with no data augmentation or random data augmentation often fail to kick the ball. Only the policy trained with GuDA consistently scores. In the easy initialization, our expert consistently solves the task, but takes a relatively wide arc to the ball and often hesitates when dribbling the ball to the goal. The policy trained with no data augmentation takes a wide arc to the ball and often loses control of it while dribbling. The policy trained with random data augmentation typically moves along straight paths and also struggles to maintain control while dribbling. The GuDA policy consistently solves the task, but does so faster than the expert. It saves time by taking a much more direct path to the ball and by dribbling without hesitation. In our physical experiments, GuDA outperforms a commonly used random data augmentation strategy and outperforms our expert demonstrator despite starting with a single suboptimal demonstration. We include additional experiments on several simulated domains in our paper that further demonstrate the utility of GuDA. We include a few examples here. Thank you for your attention, and please get in touch with us if you have further questions.